In this video by the Aggie Math Learning Center, we will discuss some key concepts regarding matrices. We will work through 3 short problems explaining the techniques for matrix addition and subtraction and matrix multiplication. Let's work through a problem requiring matrix addition. We are given the following problem. Take a few minutes to think through the problem and make an attempt. One crucial idea with matrix addition is that in order to add the matrices, they have to have the same dimensions. For example, both matrices are made up of 3 rows and 3 columns, so they are both 3 by 3. Therefore, it is okay to add them together. This rule is also true for subtracting matrices. The next step is simple. We look at the number in the first row and first column for both matrices and add them together. This becomes the number in the first row and first column of our new matrix. In this case, we are adding 9 and 18 to get 27. We can continue this process to fill out the rest of the matrix. After adding all the values, we are left with the following matrix. This is our solution. If we were doing matrix subtraction instead of addition, this process would be the same, except we'd be subtracting the value from the second matrix from the first. We will now look at a problem that takes a matrix and multiplies it by a constant. We are given the following problem. Take a moment to work through the problem. The process for this problem won't take too long. Since we are multiplying the entire matrix by a constant 3, we will just be multiplying each value in the matrix by 3. Therefore, we will get the following matrix when we're finished distributing the constant. 12, negative 21, 6, and 48. This is our solution. Now let's go through a problem that requires matrix multiplication. We are given the following problem. Pause and give the problem a try. Before you do anything with matrix multiplication, it is important that you check the dimensions of the 2 matrices. The first matrix is 2 by 3 and the second matrix is 3 by 2. For matrix multiplication to work, it is required that the number of columns of the first matrix and the number of rows in the second matrix match. For example, with a 2 by 3 matrix being multiplied by a 3 by 2 matrix, we see that the number of columns of matrix 1 and rows of matrix 2 are both 3, so it is okay for us to do matrix multiplication. The resulting matrix will have the dimensions of the number of rows of matrix 1 and columns of matrix 2, so that would be 2 by 2. Now that we have checked to see if we can do matrix multiplication, we can go ahead and do it. There are a couple of ways to do matrix multiplication, but I'll show you one way commonly known as the dot product method. In this method, in order to find the value in the first row and first column of our resultant matrix, we will need to take the dot product of the first row of the first matrix and the first column of the second matrix. If you are unfamiliar with what the dot product is, it is where we look at the first row values of the first matrix, which are 2, 4, and 7, as well as the first column of the second matrix, which are 6, 2, and negative 3. We will add the product of the first values of both of these lists with the product of the second values of both of these lists, and so forth for how many numbers there are. This will give us 2 times 6 plus 4 times 2 plus 7 times negative 3. The reason it is so important to check the dimensions of the matrices beforehand is because if the second matrix actually had 4 rows, then when we went to multiply the 4th values from both of the lists together, there wouldn't be a 4th value from the first matrix. Now back to looking at the dot product calculation. When simplified, we get that value to be negative 1. We can also find the value in the second row and first column of our solution matrix by taking the dot product of the second row of the first matrix and the first column of our second matrix, which gives us negative 3 times 6 plus 1 times 2 plus 6 times negative 3. After simplifying, we see this value is negative 34. We can follow the same process for the other 2 values such that we get our solution matrix to be negative 1, negative 22, negative 34, and 7. If these or any other concepts require some more of your attention, feel free to watch this video again, reach out to your professor or recitation leader, or utilize the free tutoring services offered at the Aggie Math Learning Center. We hope this video has helped you out.